Have you ever wondered how networks communicate with each other in a complex web of connections? Today, we will explore one such protocol, the Enhanced Interior Gateway Routing Protocol, or EIGRP. In the world of network communication, EIGRP holds a significant role. This advanced distance vector routing protocol, created by Cisco Systems, is used extensively in large networks due to its superior speed and efficiency. EIGRP uses a unique algorithm known as the diffusing update algorithm. This enables it to react more quickly to network topology changes, making it stand out from other routing protocols. Moreover, EIGRP is an interior gateway protocol designed for use within a single network. It's robust, flexible, and easy to configure, making it a popular choice amongst network engineers worldwide. But what makes EIGRP truly special is its ability to support multiple network layer protocols and its use of multicast addressing to share routing information. So, ready to dive into the world of EIGRP? Let's take a step closer and learn how to configure and verify it. To start with, we need to understand the basic configurations of EIGRP. The first step is setting up a router. This is the heart of your network, the device that will be running the EIGRP protocol and managing the flow of data across your network. The router should be properly installed and connected to your network, with the correct interfaces configured and enabled. Next, we enable EIGRP on the router. This is done through the router's command line interface, or CLI. The command we use is router EIGRP, followed by the autonomous system number. The autonomous system number is a critical part of the EIGRP configuration. It tells the router which EIGRP process to associate with the configuration commands that follow. Each router within the same EIGRP domain must use the same autonomous system number. Once EIGRP is enabled, we need to define the network. This is done using the network command followed by the network address and wildcard mask. The network address tells the router which interfaces to apply the EIGRP configuration to. The wildcard mask, on the other hand, specifies which interface IP addresses fall within the specified network. In essence, the network command activates EIGRP on all interfaces that have an IP address falling within the range specified by the network address and wildcard mask. It's important to note that EIGRP, unlike other routing protocols, does not automatically advertise all connected networks. We must explicitly define which networks to include in EIGRP updates using the network command. This gives us more control over the EIGRP process and the routing information that gets shared across the network. Remember, these are just the initial steps in configuring EIGRP. There are many other configuration options and parameters that we can adjust to fine-tune the EIGRP process and optimize our network performance. But these steps provide the basic framework upon which we can build a robust and efficient EIGRP network. With these steps, you have set the foundation for your EIGRP configuration. Let's move on to the next steps. Now that we have set up our router and enabled EIGRP, we can proceed with the rest of the configuration. Our journey into the configuration of Enhanced Interior Gateway Routing Protocol continues, and our next step is setting up the router ID. The router ID is a unique identifier associated with a router within an EIGRP autonomous system. It can be manually configured or automatically assigned. To manually set it, we use the command EIGRP router ID, followed by the desired ID. If not manually set, the router ID is derived from the highest IP address on a router's loopback interfaces or the highest IP address on its physical interfaces. Next, we configure the EIGRP stub. A stub router in EIGRP is a router that advertises a subset of its routing table. This is often used in hub-and-spoke network topologies where these spoke routers have limited resources. To configure a router as a stub, you use the command EIGRP stub, followed by the type of routes you want the stub to advertise. Now, let's move on to setting up the passive interface. The passive interface feature in EIGRP prevents the sending or receiving of routing updates on an interface. This is particularly useful when you want to stop EIGRP from sending updates out of certain interfaces, thus conserving bandwidth. To configure a passive interface, use the command passive interface, followed by the interface you want to make passive. Remember, every command we have discussed so far should be executed within the router configuration mode. To enter this mode, use the router EIGRP command, followed by the autonomous system number. As you can see, configuring EIGRP involves a series of steps that require a good understanding of the protocol. But once you get the hang of it, you'll find that it's a very flexible and efficient routing protocol. Great, you have now configured EIGRP on your router. But how do you know if it's working correctly? That's where verification comes in. Verifying your EIGRP configuration is crucial to ensure that your network is functioning as expected. Now, let's take the journey into the world of EIGRP verification. It's like checking the pulse of your network, making sure it's healthy and robust. And like a doctor with their stethoscope, we've got our own set of tools, commands that help us peek under the hood. First up, the Show IP Protocols command. This command is our gateway into the world of EIGRP. It provides a snapshot of the routing protocols running on your network, including EIGRP. From the routing process ID to the networks being advertised, it gives us a bird's-eye view of our EIGRP configuration. Next, we have the Show IP EIGRP Interfaces command. This command is like a magnifying glass for each interface running EIGRP. It tells us about the interfaces participating in EIGRP and the number of peers for each interface. It's like getting a roll call of everyone participating in the network game. Then, we have the Show IP EIGRP Neighbors command. This command is the social butterfly of the command set. It helps us understand the relationship between different routers in your EIGRP network. It shows the routers that your router has established neighbor relationships with, and the details about these relationships. It's like a networking event, but for your routers. Finally, we reach the Show IP EIGRP Topology command. This command is the map maker of our command set. It gives us the EIGRP topology table showing all the EIGRP routes known to the router. It's like the blueprint of your network, showing you the pathways of data travel. By now, you should be able to verify your EIGRP configuration. But before we wrap up, there are a few more concepts we need to explore. Remember, in the world of networking, knowledge is power, and these commands are your superpowers. So wield them wisely, and your network will thank you for it. EIGRP has some specific concepts and features that set it apart from other routing protocols. Let's learn about them. First, we delve into the concept of EIGRP neighbor adjacencies. This happens when two or more routers running the EIGRP protocol become neighbors. These routers exchange routing information to maintain consistent and accurate routing tables. The establishment of neighbor adjacencies is fundamental to the operation of EIGRP, and it's the first step in building an EIGRP network. But how does this happen? Well, EIGRP uses hello packets to discover new neighbors and maintain a relationship with existing ones. Once the relationship is established, routers exchange full routing tables and then only updates when there are changes in the network topology. Now, let's talk about an EIGRP-specific concept: dual, or the diffusing update algorithm. Dual ensures reliable and loop-free paths throughout the network. It uses metrics to determine the best path to a destination and a backup path, if available. Next, we have the feasible distance. This is the metric of the best path to reach a destination network. The path with the lowest feasible distance is considered the shortest path and is the one chosen for data transmission. Then, there's the reported distance. It's the total metric along a path to a destination network, as advertised by an upstream neighbor. In simple terms, it's the distance from the neighbor router to the destination. It's important to note that EIGRP keeps track of multiple paths to each destination and can quickly switch to a backup path if the primary one fails, ensuring high network availability. In conclusion, EIGRP's neighbor adjacencies, dual, feasible distance, and reported distance are all integral parts of how EIGRP functions. They provide a foundation for understanding the protocol's operation, and by grasping these concepts, you're one step closer to mastering EIGRP. With this, you should have a solid grasp of EIGRP and its unique features. We have covered a lot of ground today in our exploration of EIGRP. We started with a broad introduction to the Enhanced Interior Gateway Routing Protocol, where we delved into its unique functionalities and capabilities. We then moved on to the technical side of things, showing you the ins and outs of configuring EIGRP. It was a two-part process, but we made sure to break it down into manageable steps. We didn't stop there though. We dove into verifying EIGRP, ensuring that our configurations were spot on and the protocol was functioning as expected. Finally, we explored the intriguing world of EIGRP neighbor adjacencies and specific concepts, shedding light on the intricate workings of this dynamic routing protocol. We hope this journey has been as enlightening for you as it was for us. Remember, the world of networking is vast and ever-evolving. So keep exploring, keep learning. Thank you for joining us on this journey through EIGRP. Stay tuned for more insights into the world of networking on Tech Spectrum Pro.